Hi everyone, my name is Ali Iqbal. I am a Microsoft Azure Solution Architect with 7 plus years of experience. In today's video, I will show you how to use dependency injection in Azure Function. Also, I will show you how to use localsettings.json file and appsettings.json file and secret manager for storing secrets during development environment in Azure Function. Let's start. Now we will create Azure Function. We will go to the file, new, project, and we will search for Azure Function. From here we will select Azure Function template and click next. Now we will provide the name. And then we will click next. Then we will select function worker runtime, which is .NET 6.0 long-term support, and function trigger, which is HTTP trigger. We will keep remaining things as the defaults, and then we'll click create. So first we need to install two packages in order to use dependency injection in Azure Function. So let's install. So we'll right click on the project and manage and you get packages. And we'll go to the browse tab. And the first package to install is Microsoft Azure Functions extension. So this is the package. Install. Okay. Accept. The second package to install is Microsoft Extensions Dependency Injection. So this is the package. Install. Okay. So both of these packages are installed now successfully. To use dependency injection in Azure Function, we need to create a startup class to register services into the service collection. If you have used dependency injection in .NET Core, you already knows it. The name of the class that is startup is purely for consistency and it can be different. So let's create the startup class. You will click add and change the internal to public. In this startup class, we need to make sure to add the functions startup assembly attribute which comes from Microsoft Azure Functions extensions and you get package. So let's do that. So in this assembly, we will specify the type name used during startup. This specifies a class that acts as the function startup. Now we also need to make sure to inherit from the function startup abstract class. So let's do that. Now we will implement the function startup abstract class method in this class. In this lecture, we are going to take example of email sending scenario for notification purpose. Suppose you are using this Azure function to send notification emails. To do this, you are using SMTP service in the dev environment, and in the production environment, you are utilizing SendGrid, which is a third-party service to send emails. So we will create folder called services, and in this folder we will add interface and the concrete implementation for this interface. So first we will remove these unused using statements. Then we will add a folder called services. In this folder we will add a interface called email service. We will change the internal to public, and in this interface we will define a method. And in the parameter we will pass string email body. Then we will provide a concrete implementation. So in our scenario we will provide two concrete implementation. One is for SMTP and the second is for SendGrid. We will change the internal to public. Then we will inherit it from email service that we have created, and then we will implement missing members. And in the implementation we will just return a simple string, interpolated string. Now we will add a second implementation for email service, that is for SendGrid. We will change the internal to public and inherit it from email service and implement the missing members. And in the implementation we will return an interpolated string. Now we will remove the unnecessary using statements from both of these files. Now we will register the email service into the service collection in the Azure Function startup class. The startup class runs once the Azure Function host startup and builds up the service collection used to resolve dependencies. We can register our services and their dependencies in configure method of startup class with different lifetimes. Depending on the lifetime used to register the service, each execution of Azure Function gets the same or different instance of the dependencies. Azure Function supports three types of service lifetimes, same as .NET supports. These are transient, scoped, and singleton. Transient service are created upon each resolution of the service, where new instance is created every time an instance is requested. In scoped, service lifetime matches a function execution lifetime. New instance is created once per function execution. Later requests for that service during the execution reuse the existing service instance. In singleton, service lifetime matches the host lifetime and is reused across function executions on that instance. Singleton lifetime service are recommended for connections and clients, for example, document client or HTTP instance. In our scenario, we will register our email service using the transient lifetime service. Builder.services.add transient. They will pass the interface and then we'll supply the concrete implementation. In this scenario we will passing the SMTP. We are supposing that we are in the dev environment. Now we will use our email service in our Azure function. So the default function class created by the Visual Studio Azure function template is a static class, and there is a static method in this class called run. To support dependency injection via the constructor, we need the class to be instantiated with a constructor. So we need to update the function1 class from static to non-static class. So we will remove the static and also remove the static from the method, and also update the function name email notification. And we will also rename here Then we will remove the unnecessary code from here that we don't need to use. Now we will inject our email service using the constructor injection here. So first we will add our constructor. And in the parameter, we will pass our iEmail service. Then we will create an assigned field, and we will change the field name from email service to underscore because this is a private read only. And we will remove this. Now we will update this query parameter from name to email body. And the variable name also. Then we will use our email service method send email. Then we will use our email service send email method, and in the body we will pass email body, and the response we will return send email response. So finally, now we will test our Azure function by running our project. So this is a HTTP based Azure function. So we will copy the URL from here, and we will use postman to call our Azure function. We'll change get to post and enter the URL here and pass the body as a JSON. And then we will click on send. So you can see now, hi John, email send using SMTP service, because we are injected a SMTP concrete implementation in our startup class. So suppose now we are pushing our code for the production. So the only change we need to make here is change the implementation from SMTP to SendGrid. Save, and nothing needs to be changed in the Azure function because we are using the constructor injection and we are using our email service. So there is no direct dependency of our concrete implementation, that is SMTP service and SendGrid service in our function. All the dependencies will be resolved at the runtime using dependency injection via the startup class. So if we run our function again, then we hit the send button again in the postman to call our API. Now you can see hi John email send using SendGrid. If you notice that our Azure function URL is ending with function1, but we have already changed the Azure function class name from function1 to email notification when we make our Azure function class non-static from static. This is because I forgot to update the function name attribute used in the run method with the new name, that is email notification. So let's do that. So we will stop our project and copy our class name email notification and paste it here, and once again run our project. Now you can see our Azure function URL is ending with email notification. We will now test it again using Postman. So we will update the URL and click on send. So we will get the response, hi John, email send using SendGrid. So it is working fine, same as previously. We can also use other .NET packages using dependency injection in Azure Function. For example, we can use HttpClient to call REST APIs in our Azure Function by registering it in service collection in the startup class. The advantage of using HttpClient using dependency injection is HttpClient factory can create and manage new HttpClient instances, but also it works with underlying handlers. Basically, when creating new HTTP client instances, it does not recreate a new message handler, but it takes one from a pool. Then it uses that message handler to send the request to the API. The default lifetime of a handler is set to 2 minutes, and during that time, any request for a new HTTP client can reuse an existing message handler and the connection as well. This means we don't have to create a new message handler for every request, and also we don't have to open a new connection, thus preventing the socket exhaustion issue. To use HTTP client, we need to install Microsoft extension HTTP NuGet package. So I have already installed this package, so I will show you in the NuGet package. So manage NuGet packages. So you can see, so please install the version 6 of this package because we are using .NET 6.0 as our Azure function runtime. So now we will register HTTP client in the service collection in our startup class. Now we will call builder.services.add HTTP client. Now we will inject the HTTP client using the dependency injection in our Azure function class. So in the constructor parameter, we will pass I HTTP client factory, and then we create a property. Sorry, not a property but a field. And then in the constructor body, we'll call a create client method. And in our function, we will use it. So we'll take a simple example. So this is how we can call the API, REST APIs in Azure Function using dependency injection. We can also register logging related services in the service collection using dependency injection. The run method of our Azure function has the iLogger getting injected by the runtime. This is automatically done and it is not using the service collection that we set up in the startup. However, we can also inject an iLogger instance via the constructor injection using the service collection that we set up earlier. To do this, we need to move the iLogger to the constructor. So let's do that. So we'll remove it from here and add in our constructor. To find the type, and we will add a field and change it to the underscore because this is a private read only. Then we'll make a small change here. This is underscore logger. So in this code we inject in this code we inject an instance of the iLogger email notification where the generic class type represents the category name used when logging. Finally, we will register the logging related services in the service collection in a startup class. So let's do that. In the startup class, we will call a method add logging. So this is how you can register and use logging related services using dependency injection in Azure Function. There is a one typo here. This is underscore logger. We can also use this startup class to read configuration settings or connection strings from localsettings.json file in the dev environment. To do so, we need to add code in configure method of a startup class. Let's do that. So in this code, we are accessing the local setting JSON file using the configuration builder and providing the current directory. So this is the local setting JSON file. So I will add some configuration data here. For example, email info, and I will separate this with contact us. And provide some sample email address and save it. So there is one limitation when storing these configuration key values. The limitation is that the object cannot be stored as a JSON object in the local setting JSON. For example, if I do that email info and object, then contact us, and then provide the value. So we cannot do it like this because of the way the Azure function runtime loads configuration from the values object. We need to create the property exactly the same way as it is in the configuration section of the Azure functions runtime in the Microsoft Azure portal. So we will remove this section. The workaround for this is to use the colon. So when you use this like this, you can add multiple key value properties. For example, URL, and then when you are using like this, you can read all of these settings with the email info, the first word of this configuration. So if you are separating the word with the colon, this is the same as you are providing with a separate object in the local settings.json file, but this is not supported. You need to separate your configuration settings with the colon if you want to use like that. Okay. So in order to access or read these values and use in our Azure function, we have two ways. The first way is if I go to my SendGrid email service. So the first way is to use the I configuration. So for example, I will create a constructor and then I configuration and then create a field and change it to underscore, as this is private read only. And then to read the configuration value, first I'll create a variable contact us email, then underscore configuration dot get value, then provide the type of the value that we are getting is the string, and then the section that we are getting. So the section is email info contact us. So we'll paste it here and we will use in our interpolated string. So contact us at, and then we will use contact us email, save it, then we will run this project. Then I will hit enter to call our Azure Function API. So you can see contact us at example@domain.com. So we are accessing our configuration setting from the local settings.json file. The second option to access and use configuration values in Azure Function is the options pattern. The options pattern uses classes to provide strongly typed access to group of related settings. So for this pattern, first we need to create a class that will be the representation of our configurations in the local settings.json file. So new item, we will name the file as email info and change internal to public, and we create one property here. Name is contact us. Then we will register the I options into our service collection. So builder dot services dot add options, email info, dot configure, I configuration, settings, configurations, then configurations dot get section, and we will provide the section name. So our section name is email info. We will provide the first word. Okay, so if you have multiple configuration, you will get all of them with this word. For example, if we have the URL or other things like email info colon contact us or email info colon URL, so all will be get using this. So email info dot bind settings. So this code wires up the class email info into the service collection and makes it available to be dependency injected. Okay, so now we will use the configuration values in our SendGrid email service using the constructor injection of I options. Okay, so we will remove this previous written code and this one also, this also, and this also. Now we will add I options and email info and notifications, and we'll add a field and we will change it to email info, market underscore, also change there underscore, and then configurations dot value. Okay, then we will use the configuration value here using the underscore configurations dot contact us property. So now we will run our project. So now you can see the response. Contact us at example@domain.com. So these are the two ways to access the configuration settings stored in the local settings.json file in Azure Function. We can also use appsettings.json file for storing configuration settings or connection strings. By default, Azure Function template does not support appsettings.json file. However, we can update the configuration to support configuration files like appsettings.json in our startup class. In order to do so, we need to override the configuration app configuration method from the function startup class that we inherited from in our Azure Function startup class. Let's do that. First, we will create appsettings.json file. So we will add a new item and we'll search for JSON, select JSON file, provide the name, appsettings.json, add. In this file, we'll add the configuration values, email info, contact us, example@domain.com. So in this file, there is no limitation that the object cannot be stored as a JSON object as opposed to local settings JSON file. Now I will open the startup class, and in this file I will paste the code to override the configuration app configuration method. So I will paste the code below. So this code adds configuration values from a base and an optional environment specific app settings files. We have added configuration providers to the configuration builder property of iFunctions configuration builder. A function's host builder context is obtained from iFunctions configuration builder .get context method. We will use this context to retrieve the current environment name and resolve the location of configuration files in our Azure Function app folder. So now there is one problem that by default configuration files such as appsettings.json are not automatically copied to the Azure Functions apps output folder. We need to update our CS project file to ensure the files are copied. So we will open CS project file and in this we will add the code. And we will also provide the file name. We will indent our code, save it. Now we will test. So I will run the project. So I will click send to send a request to Azure Function. Now you can see our Azure Function working fine as previously, and we are getting this configuration value from appsettings.json file. We can also use Secret Manager to store connection strings and other secrets. So Secret Manager tool stores sensitive data during the development environment. To use Secret Manager, we need to install microsoft.extensions.configuration.user-secrets and uget package. So I have already installed this package. So I have installed version 6 of this package. So to use Secret Manager, we need to right click on our project and manage user secrets. And in this, we will provide our secrets. So in our case, we are using email info and then contact us. And then test@domain.com. So I've deliberately provided different value in the contact us because I will show you that the highest precedence will be given to the secret.json file if you are using multiple providers for storing connection string or configurations related data. Okay, so we will run our project. Now I will test our API again. So you can see now we are getting test@domain.com from our secrets.json file. Thanks for watching the video. If you found it helpful, please don't forget to subscribe my channel and share with others. I hope to see you in my next video. Thank you.